Welcome guys to our class. Today we are going to be looking at refraction of light. In this particular class, we'll be looking at refraction of light. We'll also look at refraction of laws of refraction, refractive index, and then we'll also discuss real and apparent depths. Then we'll now solve some problems. Okay, so that is what we're going to cover in this particular class. So our topic for today is refraction of light. And underneath we'll look at the laws of refraction, refractive index, real and apparent depth, then we'll solve some problems. So guys, if you are ready for us, we are ready for your class. But before then, if you have not subscribed, please subscribe to this channel, give us a like, give us a thumbs up, and help us to share the video, help us to invite your friends so that they can also come and enjoy this physics class that we are having in YouTube. Okay, so please, if you have any challenge, you can reach us through the WhatsApp number that's showing on your screen. Okay, contact us so that we can assist you to become better in physics. So please, if you are ready for this class, let us just go straight. So refraction of light. When you talk about refraction, what it simply means is the bending of light rays from their original direction when they pass from one medium to another. Okay, a medium can be air. A medium that allows light to pass through it can be air, it can be glass, it can also be water. These are basically the mediums that allow light to pass through them. So when light passes from one of the mediums to another, based on their densities, the light will change or it will bend. It will bend. So as I've said, refraction is the change in direction or speed of light when it passes from one medium to another due to differences in densities of the media. So the difference in density causes the light ray to bend, or it causes the light ray to change in its speed as it travels from one medium to another. Okay, so when a ray of light is incident on an air glass boundary, this is an air glass boundary. This is air and this is glass. When a ray of light is incident on an air glass boundary, it changes direction and it passes from air to glass. Now, if you look at this particular ray diagram, you will see that this is the normal. The normal is perpendicular to the boundary. Now, when the ray passes from air, which is less dense, to glass, which is denser, it will bend toward the normal. So the ray will bend towards the normal because the density of glass is more than the density of air. Also, if the ray passes from glass to air, because glass is denser than air, or air is less dense than air, the ray will bend away from the normal. The ray will bend away from the normal. So take note of this, and so that when you are drawing your ray diagram, you know how to indicate them properly. The angle between the incident ray and the normal is known as the angle of incidence, and this angle between the refracted ray and the normal is known as angle of refraction. So what I placed here is just what I've discussed already, that when light travels from a less dense media to a denser media, the refracted ray bends towards the normal. But when it travels from a denser media to a less dense media, the refracted ray bends away from the normal, and the angle of refraction is more than the angle of incidence. So if you look at it, when a ray of light travels from here, from glass to air, the angle of refraction will be bigger than the angle of incidence. Okay, so this is just the introduction to refraction of light. Now, just like reflection, there are also laws that govern refraction of light. Okay, so before we talk about the laws of refraction, we'll just look at some basic terms. I think I've already mentioned some of them already. The angle of incidence, the angle between the incident ray and the normal. Okay, and then the angle of refraction is the angle between the refracted ray and the normal. Now, when a ray passes through a rectangular glass block, you have another ray that comes out of the block, and that ray is known as the emergent ray. And so the angle between the emergent ray and the normal is called the emergent angle. So this is a ray diagram from a ray of light that passes from air to glass, then from glass to air. Now if you look at it, you see that from air to glass, the ray bends towards the normal. Then from glass to air, it bends away from the normal. And that is exactly what we have discussed before. Okay, so what we are going to discuss now next is the law of refraction. Laws of refraction and refractive index. Law of refraction and refractive. This refractive index talks about the strength of the refracting media. Okay, it talks about the strength of the refracting media. So for the laws of refraction, the first law states that the incident ray, the refracted ray, and the normal at the point of incidence all lie on the same plane. The incident ray, the refracted ray, and the normal at the point of incidence all lie on the same plane. Then the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant called the refractive index. And this law is also known as the Snell's law. So if anybody talk about Snell's law of refraction, it's just this. The Snell's law of refraction states that refractive index equals to sine of the angle of incidence all over the sine of the angle of refraction. This is the Snell's law. So take note of this, because we're going to use it a lot in solving problems. And why this is the refractive index of the second media. This is the refractive index of the second media. So when if light is traveling from air to glass, the refractive index of glass will be equals to the sine of the angle of incidence in air all over sine of the angle of refraction in glass. Also, if the ray is traveling from glass to air, it will be the reciprocal of this particular equation. So from glass to air will be sine of the angle of refraction in glass all over sine of angle of incidence in air. Okay, so if you look at these two equations, it means if you look at them very well, you see that they are, this is the inverse of this one, and this is equals to speed of light in air all over speed of light in glass. So this is how these equations are related to one another. So when you start to apply them to solve some problems, you will get a better understanding of these equations. Okay, you have a clearer and better understanding of this equation. And what I want you to take note is this equation of this particular equation, the refractive index, because this is what you are going to use to solve problems. Okay, the refractive index and how they are related, how it is related to when light is traveling from air to glass and glass to air and all that. Okay, so now we're going straight to real and apparent depths. In our day-to-day life, most of us, you may have visited a swimming pool, or you have gone to like a water body that is bright. Yes, a water body that is clear. So, but if you have been to a swimming pool, which is generally common, you will observe that if you are standing on the swimming pool and you are looking at it directly, the swimming pool is filled with water, you will discover that the depth of the swimming pool, the depth of the swimming pool will appear to be shallower to you until when you enter inside. That is when you will see the real depth of the swimming pool. That is why people are always advised to be careful when you want to use swimming pool, because what you are seeing while you are outside is not what you actually, it's not what it is. Okay, it's not what it is. And also, if you have a big bowl, a white bowl, you can do this one at home. If you have a white bowl, big white bowl, you can put a stick on the white bowl. If you put a stick or even a spoon on the white bowl, you see that if you look at it from a particular side, from one angle, you will see that the stick has bent in the water. It will seem as if it is bent in the water, but it is not actually bent. You'll be seeing the image of the stick closer to the surface than the actual image. All right. The same thing too, if you have a pin and then you put a block, a glass block on top of the pin, and you look at it directly from above, the pin will appear nearer the top of the glass block than it actually is. All these observations and experiences, they are because of this phenomenon called real and apparent depth. And this real and apparent depth is caused by refraction of light. So this is what I have represented in this simple drawing. This is the real depth of this pin. Then when you have here, an observer that is here, we see the image here. So this particular image that is here is the apparent depth. This is the apparent depth. Why this is the real depth? So if to relate this one with the refractive index given by real depth all over apparent depth. Just simple. Refractive index given by real depth all over apparent depth. Okay, so we are now going to use all the few things that we have discussed now to solve some problems. Okay. So this question 1 say what is the real depth of a swimming pool which appears to be 10 meter deep when viewed directly from above its surface? Refractive index of water is equal to 4/3. So normally questions from this they are always very simple and very short. No much stories about them. Okay, so here now you will be given apparent depth that I will use A to represent to be equals to 10 meters, because they said it appears to be so. So appears to be means apparent. Then they said find the real depth. I will use this arrow to represent real depth, and we are given refractive index to be equals to of water to be 4/3. In some cases they will give it to you to be, or they can give, you can do that now, it's simple now. They can give it to you to be 1.33. It depends on the question, but here they give it to be 4/3. So you see refractive index is equals to what? Real depth all over apparent depth. So which is 4/3 is equals to real depth all over apparent depth. That is giving us to be 10. Okay, so what you are looking for is the real depth. So make that a subject. So R will be equals to 4 times 10 all over 3. So if you work this out, you find that the real depth will be 13 meters. 13.13 meters. So which means the displacement of this particular swimming pool will be 13.13 minus 10. That would be 3.13. Okay, so this is just how to use this equation. Very simple and direct. This is another one. We see that a beam of light is incident from air to water at an angle of 30 degrees. Find the angle of refraction if the refractive index of water is 4/3. So in this particular one, we are giving the angle of incidence I to be equals to 30 degrees. We are giving refractive index of water to be 4/3. This is a jam question, so there's no need to waste much time. You see that refractive index is equals to sine I all over sine arrow. So 4 over 3 is equals to sine 30 all over sine arrow. Okay, so we know that sine 30 is equals to 0.5. So you can just do that. You can do that cross multiplication. So add that your sine arrow will be equals to 3 times sine 30 all over 4. So sine 30 is 0.5, so that will be 3 times 0.5 all over 4. If you work that out, you are going to have, this will give you 0.375. You can press that out on your calculator. So the arrow will be inverse of sine 0.375. By the time you find that out in your calculator, you have the arrow will be equals to what? 22 degrees, approximately 22 degrees. So this is the angle of refraction for this particular question. Okay, so you see the way I applied them both for real and apparent depth to find angle of incidence and angle of refraction. This is just how to use them. There's no plenty story about it. Okay. So this is your test page. Please try your hands on this. These ones, they are simple, very simple questions, and they are jam questions. That's okay. Refractive index is velocity of light in air over velocity of light in the second media. Very simple. Same thing for this one too. Very easy. So try your hands on them and then see how far you can go. Solve more problems from your textbooks. Okay, and another thing I encourage you to do is to always read your books, because we discover that as a tutor, we discover that many students don't want to read. So please, you really need to read if you want to be good in your subject area. Some of you want to become engineers and medical doctors. You have to be a good student. You have to read. Please take your learning seriously. Okay, take your learning seriously. So guys, this is where we are stopping for our class for today. But before I go, please subscribe to our channel, give us a like, give us a like, a thumbs up, click on the notification bell so that when we upload a new video, YouTube will notify you. Also, help us to share the video, invite your friends, and so that they can come and enjoy what you're enjoying on YouTube. Okay, so thanks a lot. I remain Otolo Michael. Reach us through the WhatsApp number that is showing on your screen, and we are always there to assist you. Thank you so much. We are getting calls from students all over the place, and we are assisting them. So please take advantage of this opportunity so that you can become a better you. You are welcome, and we hope to see you in our next class.